Assalamu alaikum everyone. We are starting with the 11th lecture of algebra. Now algebra is a very big topic. There are many things related with algebra. So now let me just highlight over here. This is algebra lecture 11. And what are we starting in lecture 11? In lecture 11, let me draw the straight line horizontally parallel to the x-axis. So in lecture 11, we are starting with proportionality. So when we talk about proportionality, there are two kinds of proportionality that we discuss. The first one is called direct proportionality. The second one is called inverse proportionality. Now, what is the difference between the two? When we talk about direct proportionality, that means when one quantity increases, the other also increases. For example, if I'm talking about the conversion from Pak rupees to US dollars, so this is rupees, this is dollars. If the number of rupees increases, then naturally we'll be getting more dollars. If we decrease, we'll be getting lesser dollars. So one quantity increases, the other also increases in the same direction. Inverse proportionality, this is about when one quantity increases, the other quantity decreases. If x increases, y decreases, or if x decreases, y increases. So let's look at the idea. Let's go to a book, get started from there, and let me just pick up this first thing from here, and then we can try out some basic questions, and then there will be some graphs related to it. Now, the first thing that we read over here, that is about direct proportionality. Two quantities are directly proportional if they are always in the same ratio. This can be written as a proportionality statement. Now, this is the symbol for proportionality. For example, if it says P is proportional to L, which is read as P is proportional to L, or P varies directly as L, or just P varies as L. So directly, proportional, that's what this means. You can write this as an equation, P is equals to KL, where K is called the constant of proportionality. Now, if I say, let's get started with this. Y is proportional. I'll just use the short form, proportional to X. So I'll write Y is proportional to X. How can we end this proportionality sign? We will write Y is equals to K times X. That's how we will write it. Now, the graph of a proportional relationship is a straight line through the origin. The gradient of the graph is equal to the constant of proportionality. Let's talk about this. Let's say I'm given some information. When x is 2, y is 6. Find the equation related or relating x and y. Or they can even ask, write down a y in terms of x. That means make y the subject of the equation. So how would you start with this? So let's say this is an exam type question. And first of all, even before that, it would say y is proportional to x such that, now this is the continuation, when x is 2, y is 6. So first of all, you will write y is proportional to x, y is equals to kx. Now plug in the value, y is 6, x is 2, y is 6, x is 2, and we have k times 2. So the first objective is find constant of proportionality. So that could be k, that could be h, that could be some other constant. So therefore k is 6 over 2, which comes out to be 3. Therefore, what is the equation? Therefore, the equation that relates the two, that is y is equals to 3x. I have placed 3 in place of k. So this is the equation that relates the two. That is a simple example. Now, if I draw a line, or even before that, let me plug in some values in order to draw a line. So let me just draw the grid. And over here, I'm writing x and y. And now when I have this equation, y is equals to 3x, when x is a negative 1, y is negative 3. When x is 0, y is 0. When x is 1, y is 3. When x is 2, y is 6. These are some of the values that I have. So now, if I plug in these values, the kind of equation that I'll get, let me first plug in the values. So let me get started over here, minus 1, minus 3. So let's say this is negative 1 and this is negative 3. That is 1 point over here, then 0, 0 is over here. Then over here, this is 1 and 3. And then we have 2 and 6. So now these are 4 points, as you can see, and I'm not drawing it on a graph paper. So this is just a rough diagram. Let me join it using a green line. So I think it's pretty nice diagram. And I see 1 point, 2 points, 3 points, 4 points on the line. So what we have is a straight line. That is a graph, and it's passing through the origin. So now it's passing through 0, 0, and that is what is meant over here. The gradient of a graph is equal to the constant of proportionality. If you have studied straight line coordinate geometry, even if you have not, doesn't make a difference. Y is equals to mx plus c. If I compare coefficient, then m comes out to be 3. That is constant of proportionality. This is not much needed at this time, but it is a straight line which is passing through the origin. So now this thing is all good, all done. Now just acknowledge on WhatsApp if you are all good and all clear with this. I'm picking another question over here. Let me paste it over here. And I'll go over this. Let me add some more things over here. This is exercise 1. Okay, let's have a look at it. Now it says y is directly proportional to x. We are focusing on this. Example 1. Y is directly proportional to x. Fill in the gaps in the table. So now 10 is becoming 25. So we will write y is proportional to x. Y is equals to kx. That's the first thing. Then when x is 10, y is 25. So 25 is equals to k times 10. The value of k comes out to be 2.5. Therefore, what is the equation? The equation is y is equals to 2.5x. So fill in the gaps in the table. Now, if we plug in the values of x, we'll find corresponding values of y. If we plug in the value of y, we'll find the corresponding value of x. Just like that. So there is nothing special over here. We plugged in 3. We find the value of y. We plugged in 5. We find the value of y. It's 2.5 times the other. 12, 2.5 times 12, 30. This is 100. 100 divided by 2.5 is 40. Let me just illustrate this. Y is equals to 2.5x. Y is 100. That is 2.5x. Therefore, 100 over 2.5 is x. Therefore, the value of x is 40. So I hope this is all good, all clear. Just basic maths. An example just like that. Let's move on. And some more exam type questions. something like this. Worked example 2. Now over here it says M is directly proportional to E. So M is directly proportional to E, so therefore M is equals to KE. M is 72 when E is 6. M is 72 when E is 6. You find the value of K, which comes out to be 12. Therefore, the equation is M is equals to 12E. So let me just highlight this. So this is the equation, M is equals to 12E. Now, if you plug in the value of M, you'll find the corresponding value of E. And this time, it's not exact, it's in decimals. Decimals are part of life. So now this thing is done. Let me just copy these things over there. So you can try it out later. And then there is this graph question which I want to focus on. That is over here. Now this is a conceptual question. The question says, which of these graphs shows y and x in direct proportion? Explain your answer. So first of all, when we talk about direct proportion, if x increases, y increases, but this is the opposite. If x increases, y increases. If x increases, y increases. There are two things that we need to consider. The first one, x increases, y increases, x decreases, y decreases. The gradient has to be constant. The gradient has to be constant, which is not the case over here. The gradient is constant over here. That means it has to be a straight line equation. That is the concept. And at the same time, the line has to pass through origin, 0, 0. So therefore, yes, this is the one that's only fulfilling the criteria, part C. For any graphs which do show direct proportion, what is the constant of proportionality? So the constant of proportionality is the graph. So when we plug in 4, we are getting 2. When we plug in 8, we are getting 4. So therefore, we can write when x is 2, y is 4, y is proportional to x, y is equals to kx, y is 4, actually y is 2 when x is 4. It's the other way around. Let me just correct myself. X is 4, y is 2. Let's double check. X is 4, y is 2. So this is 2, this is k, this is 4, the value of k is half. Therefore, y is equals to half x. That is the equation. Let's move further. Other types of direct proportion. Now, these are the other types in which some other relationship is given. Now it says the first one, let's focus on that. That is, if A is directly proportional to square of U. So let me highlight this. A is directly proportional to the square of U. So now it's not a linear proportion, it's a square proportion. Now the gradient won't be constant. So A is proportional to U square, A is equals to KU square. Over here, the thing is that slope gradient will not be constant. Why? Because it will not be a straight line graph. The next one, that is this. It says, let me just highlight this. If A is directly proportional to cube of U, so A is directly proportional to cube. So it could be square, it could be cube, it could be square root, it could be cube root. The third one, That is, if h is directly proportional to the square root of g. H is directly proportional to square root of g. So these are three examples that you can see over here, which is direct proportionality, but it's not a straight line. Now let's look at the first example, the worked example over here. It says P is directly proportional to square of D. So P is equals to KD square. P is equals to KD square. Now, what else is there? Find P even before that. P is 125 and D is 5. So now we are writing P is 125, D is 5, but 5 is being squared. So 25K is 125. Therefore, the value of K comes out to be 5. Therefore, P is 5D squared. Therefore, P is 5D squared. Now you can plug in D, you can find the value of P and vice versa. Find P when D is equals to 7. So when we plug in D is equals to 7, therefore this is 7 square into 5. That comes out to be 245. Similarly, find D when P is 2500. So now P is 2500. This is 5D square. So D square is 500. Therefore, D is square root of 500. And when we take a square root, we apply a positive and a negative sign. So that is the working that we did. Now let's move on. There are some questions related to table and so on. Let me just copy this thing. This is exercise 2. Some very, very basic questions. I'll do one or two of them. Let me add another page over here. Okay, let's get started with this. Now the question over here is this. Question number, let's start with 4. It says y is directly proportional to cube of x. Y is proportional to cube of x. Y is equals to kx cube. Now focus on 8 and 256 because x and y are given. So the first step is finding the constant of proportionality. So now y is 256 when x is 8. So 256 is equals to k times 8 cube. So how much is 8 cube? That is 64, and let me multiply. That is 64 into 8. That comes out to be 512. So 256 is k times 512. Therefore, the value of k is half. Therefore, the equation is y is equals to half x cube. Now this thing is done. So now I have used this knowledge. Y is 256 when x is 8, and I find the value of the constant. What's next? I can plug into, I can find the corresponding value of y. Similarly, I can plug in y, I can find the corresponding value of x. Let me work it out. So let me just work this out and let me just work this out. So now when x is 2, find y. X is 2, find y. So y is equals to half into 2 cube. That is half into 8. That comes out to be 4. So that's the answer over here. And the other one, x is unknown, y is 950. So y is equals to half into x cube. Y is 950 is equals to half into x cube. So 950 into 2, that is 1900. And let me just take the cube root of 1900 if that's possible. That is in decimals. So 1900 is x cubed, therefore x is cube root of 1900. And that comes out to be 12.39, correct to 4 significant figures. So that's how this basic question is done. Now I would like you people to try out this question and this question. Till that time, I'll simply pause the recording. So now let's look at part question number 7. Question number 7 says, if directly varies as the square of g, therefore f is equals to kg square, g is 100, f is 200. F is 200, that is k times g, which is 100 square. 200 is k times 1000. Cancel off the zeros. So k comes out to be 2 over 10 or 1 over 5. I'm just pausing the recording and stopping the class for azan. So now we found the value of k as 1/5. Therefore, the equation is f is equals to 1/5 of g square. Now the first part, that is find f when g is 61.5. So first part, find f when g is 61.5 square. Of course, you have to use a calculator and then you will get this answer. And then part B, it says given that g is positive. So second part, it says given that g is positive, greater than 0 means positive. Find the exact value when f is 14. So now f is 1/5 of g square. 5f is g square. 5 into, what is the value? 14, f is 14. 5 into 14 is g square. So that is 70 is equals to g square. Therefore, g comes out to be square root of 70 with a positive sign. Exact means do not round off. Leave the answer in the square root form. That is what is meant by exact. So that is something very important which you are looking at it for the very first time. Now, similarly, let's look at question number 8. It says that the time taken for a ball to drop from its maximum height is directly proportional to the square root of distance fallen. T is proportional to square root of distance. Let's give it the symbol d. So now in such a question, if they have not defined any variable, then you are supposed to define those variable. So t is the time taken, and the unit over here is in seconds, and d is the distance that it falls, and the distance is in meters. Now it says t is proportional to root d, therefore t is k root d. That is the first thing. Now it says given that it takes 3 seconds to drop 34.1 meter, the ball takes 3 seconds. So t is 3, this is k, this is square root of 34.1. Of course, you have to use a calculator. So 3 over root 34.1 is equals to k. So you will get some decimal value of k. So I'm not sure what this value is. I'll just leave it like this. Find the time taken for the ball to drop 15 meters. So now the equation is t is equals to 3 over square root 34.1. I can even write this value multiplied by square root of d. And now it says time for the ball to drop 15 meters. So t is equals to 3 over square root 34.1 and square root of 15. Now at this stage, now use a calculator. Instead of writing k in decimals, now use a calculator I wrote k in the exact form. So this is the exact form of k. So I wrote it as it is. Then I plugged in the value of d. Now I'll evaluate, and now I'll get the answer for t, and it's asking find the time taken. So I hope it's all good, all clear. Let's move on. So now we are talking about inverse proportionality. Let me just capture this whole image, and let me capture all images together. Let me just double check whether the recording is all good, all on. Yes, it's all on. And this is the thing that we need so that we can complete this thing. Just focus on this. And the graphs thing related to this, that will be done in the next class. Today we are just working it out. So let me just put all the questions over here. And then these graphs will be related to graphical solution of equations. So other types also. So let me just focus till here. Okay. So now we are starting. I think I missed out something. This is question 1, and I think I need to add a page more. That is, I think, this one. Now, people, let's talk about inverse proportionality. What is inverse? If two quantities are inversely proportional, what happens? If they're inversely proportional, the product of the two quantities is constant. That's one approach of stating the truth. Inverse proportion can be written as a proportionality statement. Y is inversely proportional to x. Y is inversely proportional to x. Y varies inversely as x. As with direct proportion, you can rewrite this as an equation using a constant of proportionality. Now, first of all, the thing that we need to focus is that if one thing is in the numerator, the other thing is in the denominator. That is the main thing. So let me write this thing over here, which the examiner has not written or the author has not written. So, and one more thing, x increases, y decreases, x decreases, y increases. Also, if y is inversely proportional to x, one variable, it's in the numerator. The other variable, it's in the denominator. And then again, we multiply with the constant of proportionality on the right hand side, and life is all good. Now, in this example, it says y is inversely proportional to x. So y is inversely proportional to x. Y is equals to k over x. Some people, they even ask this question, does it make a difference which side we put the k on? The answer is no. Your equation finally will come out to be the same. So someone can write ky is equals to 1 over x. That's perfectly fine. The value of k will different, but if you make y the subject, you will get the same answer. So now what do we have? We have this thing that the value of x is given, the value of y is given, and then x is given, find y, and then y is given, find x. That's the working that needs to be done. Now, first of all, we have when x is 10, y is 20. That is given over here. When x is 10, y is 20. So 20 is equals to k over 10. Therefore, 200 equals to k. Therefore, the equation is y is equals to 200 over x. Now, if I plug in 1 and 5, when x is 1, so let me write over here, y is equals to 200 over x. When x is 1, y is 200 over 1, which is 200. When x is 5, y is 200 over 5, which is 40. Now you see the value of x is increasing, but the value of y is decreasing in the same manner. And what else is there? Now y is given as 100. Now y is equals to 200 over x. Now y is given as how much? Y is given as 100. Therefore, 100 is equals to 200 over x. Therefore, x is 200 over 100. Therefore, this comes out to be 2. So just double check the answer. We got these values. This is the one that we just got. This is 40 from before. This is 200 from before. So that's 200, that is 40, that is 2, and that's how we got this answer. Pretty basic question, just like that. Now, this has something to do with graph. So this graph we will study in the next lecture. That is one thing that needs to be explained. And again, some questions like this. Let me explain question number 6. Question number 6, it says, W is inversely proportional to Z. W is inversely proportional to Z. W is equals to KZ, K over Z. It's inverse. Now it says W is 15 when Z is 4. So W is 15 when Z is 4. W is 15, Z is 4. Therefore, 15 is equals to K over 4. Therefore, K comes out to be 60. Therefore, the equation is W is equals to 60 over Z. This is the equation that we have. Now it says find Z when W is 25. Part 1. Find Z when W is 25. So therefore 25 is 60 over Z. Therefore Z is 60 over 25. That is 12 over 5. Leave the answer as a fraction. So part A is done. Part B. Explain what happens to Z when W is doubled. That's a good question. Part B. So now what happens to Z when W is doubled? So W is 60 over Z. If W becomes 2W, what happens to Z? Z should be half of W. Z should be half of Z. Why? Because this product should be the same. I can write this thing as WZ is 60. Make sense? So if I write W as 2W, and this is unknown, and this is 60, if you want this to be the same, therefore this should be half W. This 2 and this 2 should cancel out. If one quantity is double, the other one has to be halved. So the opposite of double is half. So that is why we get this thing. Similarly, part C, what does it say? What happens to W when Z is trebled? So again, WZ is 60. What happens to W if Z is trebled 3 times? So if this is 3Z, then W should be 1/3 of Z. So therefore trebled or tripled. The opposite is 1/3. And that's how this question is done. So this is exercise 2, and that is how this is explained. Why is this thing is done? Other type of inverse proportions. So let me just write this thing, copy this thing over here. Let me do a question on this. So now this thing is there, just like we did in direct proportion. And let me select some questions from here. So this is exercise 3. This goes like this. And let me select a few questions from here. So let me just select this. and I would like all these questions solved for the next class. I'm deliberately not giving the answers because you should have the audacity and the confidence to do it on your own without looking at the answer. I can share the answers once you have submitted me the working. Okay, so now let me focus on this. Now it says that other types of inverse proportion, A is inversely proportional to square of u. So A is in the numerator, square of u is in the denominator. K, we write it on the right hand side. So A is K over u square. Similarly, A is inversely proportional to cube of u. So we have A is inversely proportional to cube of u, and then we change it into a constant and put an equal sign. And then we have the third one, h is inversely proportional to square root of g. So h is inversely proportional to square root of g. H is inversely proportional to square root of g. Therefore, h is equals to k over root g. Just look at this example. Y is inversely proportional to cube of x. So therefore, y is inversely proportional to cube of x. Therefore, y is equals to k over x cube. And then it says x is 4, y is 10. So x is 4, y is 10. That is k over 4 cube. 4 cube is 64. Therefore, k comes out to be 640. Therefore, the equation is y is equals to 640 over x cube. It's the same story as before. Find the value of x when y is 50. So when y is 50, therefore 50 is equals to 640 over x cube. Therefore, x cube is 640 over 50. Hence, you make x the subject. That is cube root of 64 over 5, which this answer definitely will come out to be in decimals. So that is the basic idea of this thing. You have all these questions. So for the next class, try them out. So take care till the next class.